When you woke up this morning, poured your coffee, and maybe glanced at the clock on your wall, you made this absolute unquestioned assumption about how the universe
Well,
works.
absolutely. Yeah, we all do it.
Right. It's an assumption so deeply hardwired into your brain, you probably don't even realize you're making it.
We basically all operate under the assumption that right now is the only thing that is truly real.
Exactly.
I mean, the whole human experience is built on this sensation that the past is just a memory, completely beyond our reach, and the future is this blank, unwritten void waiting to be constructed.
Yeah, we experience time like a river. Like you're sitting in a little boat flowing strictly from the past through the present and heading toward the future.
Right.
But what if that river is just a complete illusion? What if the past hasn't actually disappeared? And what if, and this is where it gets genuinely eerie to think about, what if your future already exists in its entirety right now?
Well, questioning those fundamental assumptions about how we perceive time, it's it's absolutely essential if we want to understand the actual mechanics of the cosmos.
Yeah.
When you strip away our localized human perception, the physics of time travel, and the fundamental structure of time itself, it presents a reality that is far stranger than any science fiction narrative.
Okay, let's unpack this, because our deep dive today is based on a stack of notes and themes derived from Ziko's space stories.
It's a fascinating collection of concepts.
It really is. And our mission here today is pretty bold. We are going to attempt to completely shatter your everyday perception of time.
We're definitely going to try.
Yeah, we're going to explore the highly debated physics of time travel and hopefully arrive at the shocking cosmological possibility that your future is already written.
It's a heavy topic for sure.
So let's start by challenging that cozy assumption you have that the past is gone forever. Because the math suggests the past is still very much out there as a physical location.
Right, it exists. The problem is just that the universe might actively prevent us from ever returning to it.
Yeah, and why is that? Why is the past so strictly off limits?
Well, to understand that, we have to look at causality. I mean, when we talk about time travel backward, we aren't just talking about a fun historical vacation to see the Romans.
Right, right.
In actual physics, traveling to the past represents a catastrophic threat to the fundamental logic of reality.
We should probably look at the classic grandmother paradox to ground this. I think anyone who follows sci-fi knows the basic setup, right?
Yeah, it's a staple of the genre.
So you build a time machine, travel back a few decades, and accidentally prevent your grandparents from meeting.
Just a tiny mistake.
Exactly. Maybe you just delay one of them by 10 seconds so they miss the train where they were supposed to lock eyes.
Right.
But then the ripple effect is that your parents are never born, which means you are never born.
And if you were never born,
You couldn't have built the time machine to travel back and stop them in the first place.
which means they do meet, you are born, and you do travel back. It creates this closed causal loop.
It just feeds into itself endlessly.
Yeah, and causality, that strict, unbreakable rule that a cause must precede an effect, is the bedrock of our universe.
So the paradox kind of breaks the bedrock.
Completely. The paradox creates a scenario where the cause eliminates its own effect, which then eliminates the cause. The mathematics of the universe simply cannot process this.
But wait, I want to push back on that, though. When you say the mathematics can't process it, what is physically stopping me?
What do you mean?
Well, because the source notes mention theoretical models where traveling to the past is mathematically possible, specifically using something called closed time-like curves. What is that actually describing?
Ah, right. So a closed time-like curve is a concept derived from Einstein's equations. I mean, imagine space-time as a physical fabric.
Okay, like a big rubber sheet.
Yeah, exactly. If you have an object with enough mass and rotation, like a supermassive black hole, it twists that fabric so violently that the directional arrow of time actually folds back onto itself.
Oh, wow. So it makes a loop.
Right. A spacecraft following that physical curve wouldn't just be moving through space. It would eventually arrive at a coordinate in its own past.
So the road backward technically exists, but obviously we don't see the universe collapsing into paradoxical loops every day.
No, thankfully we don't.
So the source material highlights two main theoretical solutions to this. The first one, which is championed by physicists like Professor Brian Cox, is a cosmic censorship rule.
Yes, the censorship conjecture.
But that sounds, I don't know, suspiciously like magic. Like, how does a mindless universe censor an action? It's not an editor sitting at a desk with a red pen.
No, it isn't an active conscious editor, no.
Hmm.
The mechanism behind cosmic censorship is much better understood as a probability constraint.
Okay, break that down for me.
Well, in quantum mechanics, every single event has a probability. The theory suggests that the probability of any event occurring that would create a causal paradox simply drops to absolute zero.
Wait, really? So if I'm standing there in the past trying to delay my grandfather, what happens? My car just won't start.
Your car won't start, or you trip on the sidewalk, or a bird distracts you.
Seriously, just random bad luck.
Essentially, yes.
Yep.
Not because the universe knows what you're doing, but because the only sequence of events mathematically allowed to unfold are ones that remain consistent with the history that already happened.
Wow, you are constrained by consistency.
Exactly. Whatever you do in the past was already part of the historical record. You were always there, tripping on the sidewalk. You cannot change the sequence. You can only fulfill it.
Man, that feels incredibly deterministic, like you have no agency at all.
It does feel that way, yeah.
But the second solution in the notes is entirely different, and it completely abandons that consistency rule.
The multiverse approach.
Right. It's the idea that traveling to the past instantly creates a brand new parallel universe, like a completely split timeline.
Yes.
So I arrive in the past, and I can just do whatever I want. I can stop the grandparents from meeting, and it doesn't matter because I'm in a newly spawned reality.
It solves the causality problem elegantly, honestly. I mean, the timeline where you were born and built the machine remains perfectly intact.
Oh, I see.
Your arrival simply initiates a branching pathway in the multiverse.
But hold on, this is where the physics seem to break down for me. Where does the energy come from to spawn an entire parallel universe?
That's a great question.
Right, because a universe contains billions of galaxies, dark matter, infinite energy. Are you saying the mere act of me stepping out of a time machine instantly conjures an entire cosmos out of literally nothing? That violates the conservation of energy.
Yeah, that is a highly perceptive objection. But the mechanism isn't actually creating new mass or energy out of the void.
Oh, it isn't.
No, this relates to the many worlds interpretation of quantum mechanics. In that specific framework, the universe is already a vast superposition of all possible states.
Okay, so they're all already there.
Yes, all these realities exist concurrently within an overarching mathematical structure called the universal wave function.
Ah, so I'm not generating a new universe with my time machine.
No, not at all. By traveling backward and taking a paradoxical action, you are simply shifting your localized consciousness into a different pre-existing branch of that wave function.
So I just become entangled with a different historical outcome.
Exactly.
But wait, that means I'm permanently exiled?
Yeah.
I can't ever return to the specific branch where I originated? Like the timeline where my actual life happened is mathematically sealed off from me forever.
You're trapped in a branching reality of your own making, yeah.
That is terrifying. So going backward is either a rigid chronological prison where I can't change anything or permanent chronological exile.
Pretty much. Pick your poison.
Geez. Well, moving backward obviously requires extreme quantum gymnastics. But transitioning to the physics of moving forward reveals a completely different cosmological reality.
It really does.
Because traveling to the future isn't a mathematical headache at all, right? It's basically a built-in feature of the universe.
Moving forward relies on mechanisms we have thoroughly tested and proven. I mean, to understand the shift, we have to look at Albert Einstein's theory of relativity.
Right. Einstein changes everything here.
He really did.
Okay.
Prior to Einstein, the scientific consensus was that time was just a universal constant, like an absolute ticking clock sitting outside the universe, governing everything at the exact same rate.
But Einstein realized that wasn't true. Time stretches and bends. It's entirely relative to the observer.
Yes.
But why? The sources walk through the famous spacecraft scenario. You know, you fly away in a ship near the speed of light, you age 1 year, but you return to Earth, and hundreds of years have passed.
The classic twin paradox setup, yeah.
Right. You are a literal time traveler to the future. But the notes don't really explain the underlying mechanism well. Like, why does speed dictate the flow of time?
Well, the mechanism hinges on one absolute truth of our universe. The speed of light is constant for all observers, regardless of how fast they are moving.
Okay.
Let's visualize this with a thought experiment. Imagine a clock that works by bouncing a single particle of light, a photon, between two mirrors.
Up and down, tick and tock.
Exactly.
Okay, I'm picturing it. I have a light clock sitting on my desk. The photon bounces straight up and straight down.
Good. Now imagine placing that exact same light clock on a transparent train moving incredibly fast past your desk.
Okay, the train is zooming by.
Right. To the person riding on the train, that photon is still just bouncing straight up and down.
That makes sense.
But to you, standing still and watching the train zip by, The photon isn't moving in a straight vertical line.
Because the train is moving forward while the photon is traveling up.
Exactly. Because the train is moving forward, the photon has to travel on a diagonal path to hit the top mirror and another diagonal path to hit the bottom mirror.
Right, it's tracing a zigzag shape through space as the train moves.
Yes. And a diagonal line is longer than a straight vertical line.
Oh, wow. So the photon on the train has to cover a greater physical distance than the photon on my desk.
Precisely. But remember the absolute rule, the speed of light cannot change.
It can't speed up to cover that extra diagonal distance.
No, it can't. So if the speed of the photon is strictly locked and the distance it has to travel is longer, then mathematical logic dictates that the only remaining variable must change.
Time.
Time itself must slow down for the train. For the speed of light to remain constant, the ticking of the clock on the train must literally stretch out.
Here's where it gets really interesting. Because, it's so tempting to dismiss that light clock as just an abstract theoretical puzzle.
A lot of people do.
But we have actual physical proof that this stretching of time governs our daily lives. Like, this source material references the Hatfield-Keating experiment.
Oh, that's a brilliant experiment.
Right. They didn't use trains. They used commercial jets. They synchronized highly precise atomic clocks, kept one on the ground, and flew the others around the world on passenger planes.
And when those planes landed, the clocks were compared.
And they were different.
The clocks that had been moving at high speeds were measurably behind the clock that stayed on the ground. They had literally experienced less time.
That is just insane. The mechanism you just described with the light clock was happening to the actual atoms inside those devices.
Yeah, it really was.
And it's happening right now with our GPS satellites, isn't it?
It absolutely is.
Yeah.
Those satellites are orbiting the Earth at roughly 8,700 miles per hour.
Wow.
Because they are moving that fast, time is ticking slightly slower for them than it is for our smartphones down here on the ground.
So if the software engineers didn't mathematically adjust the satellite's internal clocks to account for that relativistic time dilation...
The navigation system in your car would accumulate errors so rapidly it would be completely useless within a matter of minutes.
That is mind-blowing. Time dilation is literally a highly practical engineering constraint.
It is. We deal with it every single day.
But, think about the implications. If we have to constantly adjust our global infrastructure because a satellite's now is different from my now, that forces a massive philosophical shift.
It completely upends our intuition.
Yeah. My everyday experience of the clock ticking on my wall is just a localized illusion. There is no master clock for the universe.
Exactly. And if we connect this to the bigger picture, the absence of a universal now fundamentally dismantles how we visualize reality.
How so?
Well, if your present moment is unique to your coordinate and velocity, and someone else's present moment is uniquely theirs, we need a cosmological model that can hold all of those different nows at once.
Which brings us to the core concept of this deep dive, the absolute culmination of Einstein's math, the block universe theory.
Yes. The block universe.
If time is completely relative, then reality isn't just a single frame of existence moving forward. Space and time have to be, permanently fused together into a four-dimensional architecture.
That's the only way the math works. We navigate 3 spatial dimensions easily, up, down, left, right, forward, backward.
Sure, we do that every day.
The block universe model simply treats time as the 4th geometric axis of this structure. And the critical insight is that this 4-dimensional block is static.
Static, meaning it doesn't change.
Exactly. The past, the present, and the future all exist simultaneously within it.
Okay, to ground this, let's think about how we perceive space. I am sitting in the studio right now. I am not in London, and I am not on the surface of Mars.
Right.
But I don't doubt for a second that London and Mars physically exist right now. Space doesn't vanish just because I'm not occupying it.
That's a perfect analogy.
So the block universe argues that time operates by the exact same geometric rules. Time doesn't vanish when you aren't occupying it.
No, it doesn't.
The past isn't erased, and the future isn't blank. They are literal, physical locations in the space-time structure.
What's fascinating here is the sheer magnitude of that structure.
Yeah.
If you could step entirely outside of space-time and view the block universe from a higher dimension, you wouldn't see a universe evolving.
What would you see?
You would see a rigid, complete object. At one coordinate, deep within the block, the primordial plasma of the Big Bang is swirling. At another coordinate, A massive asteroid is impacting the Yucatan Peninsula.
Wow. And at this specific coordinate right here, you and I are having this conversation and the listener is hearing it.
Yes.
But crucially, further down the block, along that fourth temporal axis, the events we consider the future are already sitting, though.
They are fully realized.
Like our distant descendants colonizing other star systems, that reality is already fully formed and physically occupying its coordinate in the block right now.
Yes, it is just as real as this current moment.
I've often heard it compared to a movie on a DVD. Like the opening scene, the climax, the end credits, they are all permanently carved into the physical data of the disc at the exact same time.
The DVD analogy is really useful for visualizing the simultaneous existence of all events. Yeah.
But there's a catch.
Well, we must refine it to account for causality. It isn't just a collection of random scenes stitched together.
Right, because of the paradox stuff we talked about earlier.
Exactly. The events at coordinate A structurally support and cause the events at coordinate B. The asteroid impact is physically connected through a long chain of physical interactions within the block to our current conversation.
Oh, I see.
The block is a rigid web of cause and effect, completely solidified from beginning to end.
It's like an entire topographical landscape of events. You don't play the landscape to create the mountains and valleys. The terrain is just there.
That's a beautiful way to put it.
Everything that has ever happened to you and everything that ever will happen to you is permanently embedded in this frozen block of space-time. The day you were born and the final day of your life exist concurrently.
It replaces a cosmos of chaotic, unpredictable unfolding with a cosmos of profound geometric totality. The architecture is already finished.
Man. So what does this all mean for us? If we step away from the abstract geometry and look at the human experience, this presents a massive friction point.
The free will debate.
Yeah, if the block is completely static and my future coordinate is already sitting there, fully formed, do I actually have free will?
It's a tough pill to swallow.
When I decided to pour coffee instead of tea this morning, was I actually making a choice or was I just reading a script that was finalized at the birth of the universe?
This raises an important question that physicists and philosophers continue to debate furiously. I mean, if the block universe is the true nature of reality, it heavily implies a philosophy known as eternalism or strict determinism.
So no free will at all.
Under strict determinism, no. The sensation of making a choice is simply what it feels like for your brain to process the localized data at that specific coordinate.
It's just the subjective experience of computation.
Exactly.
I feel like I'm weighing options, but the outcome of that weighing process is structurally required by the events that preceded it in the block.
Yeah.
The choice was always going to resolve exactly the way it did.
Now, some argue this negates free will entirely, but others argue for something called compatibilism.
Compatibilism, what's that?
It's the idea that your internal processing and your desires actually are the mechanisms that determine the next slice of the block, even if the entire block is static from an outside perspective.
Oh, so my choice is basically the glue holding those two slices together.
Exactly. Your choices matter because they are the physical links in the causal chain. You are still the author of the action, even if the book has already been printed.
The experience of the narrative remains incredibly rich, regardless of whether the ink is already dry.
That's a great perspective to have.
But it leaves us with one highly provocative puzzle to examine. And it builds on everything we've broken down today regarding this fixed 4D architecture.
What's the puzzle?
Well, if the past, the present, and the future are entirely static, if the dinosaurs and our interstellar descendants are all physically out there right now in the rigid fabric of space-time, then perhaps the ultimate unsolved mystery of physics isn't what happens next.
Because the math implies we already know the structural answer to that.
Exactly. Maybe the real mystery is why human consciousness is constrained in such a bizarre way. Like, why are we only capable of experiencing this massive static block, one single infinitesimally thin slice at a time?
That is the crux of the enigma. Physics can describe the block, but it cannot currently explain why the observer's mind requires a sequential flow.
It just doesn't make sense.
Why does consciousness act as a moving spotlight in a universe that does not fundamentally possess a moving present?
Are we just a spotlight of awareness dragging itself across a dark stage that has already been completely built, illuminating just one scene for a fraction of a second before being forced to move on?
The physical universe might be static, but our minds are trapped in the illusion of flow.
It really makes you look at the clock on your wall differently. We're going to leave you to ponder that spotlight moving through your own fixed block of time today. Keep questioning the mechanics of your universe. Keep challenging the assumptions you make about the reality right in front of you, and we'll see you in the next deep dive.